Okay, so we'll finish up today by looking at the appendix again in the back of the book, which is on complex numbers. We already went over adding and subtracting, okay, so we did that. We're going to look at multiplying and dividing. So that's the last two things in this section. Now, we ended with this yesterday, but just as a reminder, I is the square root of -1. It's a definition. And then we figured out what I squared was. What was I squared? Yep. -1. I squared is going to come up when we do multiplication and division. So anytime you get I squared, you should always change it to a -1. Right? Don't ever leave a final answer with I squared. That's what I just said. Okay, any questions on that? All right, so there's not really a ton to explain. I'll just show you the multiplying, then we'll go right into an example. So multiplication of complex numbers, it's pretty much like FOIL, or some people just call it the double distributive property. So if you've got two complex numbers, when we get to a real problem, it'll be something like this. Okay, it'll all be numbers. You just multiply the first, outer, inner, and last. When you multiply the last, that's where the I squared comes up. Because you have an I times another I. So remember, all that really I squared means is -1. So whatever you get when you multiply B and D, you just change the sign of it. That's what I squared is going to do. It's going to multiply it by -1. But we'll go through it. Okay, so again, use FOIL if you remember it that way, or it's the distributive property twice. Once for A, once for BI. Well, that's it. That's all we need to know to learn how to multiply. Okay, so let's multiply these two together. 2 plus I times 1 minus I. Okay, so we start with 2 times 1. And Olivia, if I do that, 2 times 1 gives me 2. And then 2 times -I. Tyler?
2 times -I.
Yeah.
-2i.
Nice, -2i. 1 times I. About that?
Oh, 1i.
Just 1i.
Just I.
Or you can just put I, that's fine too. And now this part, we'll do it in 2 steps. Positive times negative. What's a positive times a negative? Negative. And now it's I times I. Yeah.
I squared.
I squared.
Yes.
Very good, Mr. Roy. I squared.
What is this class mistake?
This is trick.
I can do that.
We're doing imaginary numbers. So now, we've got some like terms there.
So let's go.
-2i plus I. That's just a -I. Now, minus I squared. But what did we just say I squared is equal to? -1. So that's the part we have to change. I squared becomes -1. So 2 minus I minus -1 plus 1. So plus 1. And then we've got more like terms. 2 plus 1. 3 minus I. So there's our answer. So this is same idea. 8 plus I times 3 plus I. Joe, can you walk me through my first step?
You gotta do FOIL, so you can put the 8 with 3 and the 8 with the I.
Right, 8 times 3, 8 times I, okay?
And then you gotta put the I with the 3 and then put the other I.
And that would be I squared. Yep.
And
So now, yeah, okay, you want to keep going?
you gotta combine the 8I and the 3I to get 11I.
Try to make my ones look different than I's.
Then you gotta turn the I squared into a 1, -1.
Yep.
And then you combine 24 and -1 to get 23.
23 plus 11I. Perfect. So multiplying two complex numbers, it's pretty quick. Doesn't really take too long. Questions on that? All right, so We're going to talk about division, but the first thing I have to show you before we do that is what's called a conjugate. So a conjugate, first thing I'm going to show you the symbol. So if you had a complex number a plus bi, and we'll call that z. So we have a complex number z, it has a real part, it has an imaginary part. Could be whatever, a could be 3, b could be 6, whatever they are. This symbol, when you put a bar on top of the z, that means conjugate. I still haven't told you what a conjugate is, how you find it, but that's the symbol for a conjugate. You put a bar on top of the z. And all the conjugate means is if your original number was a plus bi, the conjugate is a minus bi. So all I did there was I changed the sign of the imaginary part. Or a shorter way of saying change the sign is just to say negate. It means opposite. Okay, so to find the conjugate of a complex number, just negate the imaginary part. Change the sign. So if it's negative, make it positive. If it was positive, make it negative. Okay, so let's just go through a couple examples. On the left column, I've got a complex number. On the right column, I want to write the conjugate. So the first one is 3 plus 4i. What would be the conjugate of 3 plus 4i? Yep.
3 minus 4i.
Yep, 3 minus 4i. How about negative 8 minus 2i? What would be the conjugate of negative 8 minus 2i? Matt?
Would be negative 8 plus 2i.
Exactly, perfect. So you get negative 8, that part stays the same. The imaginary part changes. How about 5i? Yep.
Oh. Oh, wait, negative 5i.
Negative
I got
5i.
a question. Does the little line over the z mean it's the conjugate or not the conjugate?
Conjugate.
What does the regular z mean?
Just the regular number. So the one on the left is the regular, the one on the right is the conjugate of the one on the left. So if you're a little weird like 5i, you're not sure what happened there, think of it as 0 plus 5i. The conjugate is 0 minus 5i. How about 3? Yep,
Stays at 3.
stays 3. Okay, think of this as 0 plus no imaginary part. The conjugate is 3 minus no imaginary part. Well, plus 0 minus 0, it's the same thing. So it's just 3. That's what we would normally write. Okay. Any question on conjugate? All right. So let's take a look at what happens when you multiply a number and its conjugate together. So we're going to do multiplication again. But this time we're going to multiply conjugates and see what happens. 3 minus 4i, 3 plus 4i. Now just by looking at that, I already know the answer is 25. There's a very quick way I can do that in my head without foiling. We'll foil it, but then I think you'll see a pattern. Okay, so let's go through it. So when we foil, we get 3 times 3, which is how much? 9. Now I get 3 times 4i, which is 12i. And 3 times negative 4i. What happens there?
12's cancel.
The 12's cancel, right? You get 3 times positive 4i, 3 times negative 4i. When you multiply conjugates, the outer and the inner don't make a difference. You don't need to do them. They always cancel. And now the last part. Well, it's a negative times a positive. So that's a negative. 16i squared. Now, I squared is what number? So it's 9 minus 16 times negative 1, which is like 9 minus minus 16, which is really 9 plus 16, or what I said to start, 25. So the shortcut to doing that without having to FOIL it, and again, this only works with conjugates, take the first number, square it. Take the second number, square it, and add them up. And if you're like, well, should I square 4 or should I square negative 4? It doesn't matter. They're both 16. So just take one of the numbers, square it, take the other number, square it, and add them up. And notice the final answer doesn't have I in it. That's important. Okay, multiplying conjugates, all the i's disappear. So if we wanted to do this one, what's the first number I would square? 5. Second number? 4. Done. That's the answer, 41. If you don't like the shortcut, you can FOIL it every time. Just do it that way. Okay, shortcut only works for conjugates. You cannot use that shortcut on something like that. You have to FOIL it all out. Okay. Any questions on that one? All right, so we've done conjugates. Why did you look at that? Because that's how you do division. Okay, we're going to use the conjugate when we do division. So the problem with, let's say something like that, you can't leave I in the denominator. Okay? You have to get rid of all the i's in the bottom. It's okay to have i's in the top, but not the bottom. So how do you get rid of all the i's? You have to multiply by something that would cancel them out. Well, we just learned if you multiply conjugates, all the i's cancel out. So that's how you do division. So to divide two complex numbers, you're actually going to do multiplication. And what you're going to do is multiply the top and the bottom by the conjugate of what's in the bottom. So to divide two complex numbers, multiply top and bottom by the conjugate of what's in the bottom. And that will get rid of all your i's in the bottom. Okay, so we'll look at two problems with division, and then that'll be the end of this part. Okay, that'll finish the appendix in the back of the book. And then again, the next section is 5.3. We're going to split that into two parts. A little bit of it today, and then the rest on Monday. Yeah, can you tell me what I would do first? So the example is 1 divided by 3 plus 4i.
What you would do is you would multiply the denominator by its conjugate, and the top two.
And the top. What is the conjugate?
Conjugate should be 3 minus 4i.
3 minus 4i. Now the top, that one's pretty easy. That's just a single distributive.
You basically just copy it because it's just 1 times it.
Right. All right. There wouldn't, even if that wasn't a 1, you wouldn't be foiling the top. So, but this time it just stays the same.
And then you can do the trick you showed us on the bottom where you square 3 and square 4, and you add them.
So what would you get when you multiply out what's in the bottom?
See, 3 squared is 9, and 4 squared is 16, 9 plus 16 is 25.
25. Okay. So we're almost there. When we write an answer, it has to be in standard form. That means you have a number here, plus or minus, a number here, and then an I. That's how your final answer should look. This one doesn't quite look like that. So to make it look like that, you just write each number in the top over 25 separately instead of all together. So you put the 3 over the 25, minus, because you have a minus, 4 over 25, and then you put the I next to it. That's how you would see an answer on the test. Not a huge amount of work at that last step. Just write each number separate with the 25 on the bottom. Now, if this fraction was like 5 over 25, yes, you could reduce it. Okay, so if you get something that reduces, go ahead and do it. That doesn't. Any questions on that? Okay, so let's try one more with division, and then that'll finish this part. This time we've got i's in the top and the bottom. So I want to multiply by the conjugate of what though? The top or the bottom? Yep, the bottom. Okay, whatever's in the top, it is what it is. But the bottom you want to use for the conjugate. Okay, and what's the conjugate of what's in the bottom? Elise?
5 plus 12i.
5 plus 12i. Now the top I'm going to have to FOIL out. But the bottom I can do pretty quick. 5 squared is 25. What's 12 squared?
144.
25 plus 144? 169. So when you're done, your problem is going to look something like this. Real part, I don't know if it's going to be plus or minus. We'll see. Imaginary part, it's going to be over 169 and over 169. Okay, so we just have to figure out the top. All right, so when we FOIL, Waleed, 1 times 5 gives me 5. 1 times 12i is 12i. What about 5 times 4i? 20i. 12i and 20i, combine them together.
2? No. 32.
32i. And now the last part. It's 48i squared, which is what number? Yep.
Your I squared will be negative 1, and then you multiply the 48 by the negative 1 to make it negative 48.
Right. So it's going to be negative 48.
And then you can combine the 5 and the negative 48.
Yep. Any questions on how we got negative 48? So the 4 times 12 gives you the 48, and the I times I gives you the negative. So now Shelby just said we can combine 5 minus 48, which is how much? Negative 43 plus 32i over 169. But now I can write my final answer. It's going to be negative 43 plus 32. Both of those over 169, and just make sure you put an I next to it. Real part, imaginary part. We don't need the box around it. It's just what I was showing. Okay. Any question on division? Good. So the last thing we're going to look at is part of section 5.3, and we're going to start to see the connection between, we did polar coordinates earlier in the week, we just did complex numbers. How do the two go together? All right. Well, before we get into the complex plane, what we just did here, it's not super bad. It's not that hard to do. But instead of writing complex numbers this way, if we can write complex numbers in polar, all of this goes away. You don't have to do any foiling, combining like terms, changing I squared to negative 1, writing it as 2 separate fractions. You don't have to do any of this in polar. It's much, much faster. In fact, you can pretty much look at a problem and do the whole thing in your head in polar. So we just have to learn how do you write one of these numbers in polar. And that's going to tie into what we learned earlier in the week. First, I'm going to show you something even simpler though, which is just graphing complex numbers. So this is not an XY axis. Okay, this is the complex plane, okay, designed for graphing complex numbers. So the way the complex plane works is the real axis takes the place of the x, the imaginary takes the place of the y. So when you want to graph a complex number, like the first one, what's the real part of 2 plus 3i? 2. What's the imaginary part? 3. So it's just like graphing the point 2, 3. The real part is 2, So I go right 2 on the real axis. The imaginary part is positive 3. So I go up 2, 3, and there's the answer. The direction, the positive and negative is exactly the same as what you're used to with an XY axis. Positive is right and up, negative is left and down. All right, so let's look at this one. Tyler, how would I graph 4 minus 8i?
You go right 4 and down 8.
Yep, that's it, right 4, down 8. That's 4 minus 8i. Just don't mix up which axis is which. Real is horizontal, imaginary is vertical, and I think on the test the axes are actually labeled. So just look at the labels. How about negative 8? How do we get to that one?
Or would you just go down 8? Oh, no, wait. To left, right?
Left 8, because that's real, right? There's no I there. Left 8. Now let's look at this one, 5i. How would you do 5i, Elise?
Up 5.
Up 5, because the imaginary axis is up and down. And that's how you graph. Okay, so on the test, I think there's 2 questions like that. They're not multiple choice. You just have to graph the point yourself. So any questions on graphing complex numbers before we look at the last thing here today? Okay. So the last thing we're going to look at is how do we write complex numbers in polar. The advantage to doing this, I already told you, it makes multiplication and division extremely fast. There's no foiling, there's no conjugates, there's no I squareds. All of that goes away. It's not even that hard to do anyway, but we can make it even easier if we write complex numbers in polar. So the way we've been writing complex numbers is real part plus or minus imaginary part. Now, I know normally I put the I after it, like that. It doesn't really matter if you put the I before or after it. It's like doing 2 times 3 or 3 times 2. It's really the same thing. And I'm using X to represent the real and Y to represent imaginary because it ties in with what we just did. X is real, Y is imaginary. That's why I'm using X and Y now. So it helps you remember the connection with the graph. Okay, that's called rectangular form. Okay, so that's the kind of coordinates we learned about, way back when you start graphing. Rectangular form, you've got coordinates like this, and you move left and right, and you move up and down. Okay. Well, the other kind of graphing is polar. Okay. In polar, you don't move left, right, and then up, down. What are the 2 things that you need when you write a coordinate in polar? Yeah?
You need the radius and you need an angle.
We need a radius and we need an angle. That's how we do it with real numbers. That's how we do it with imaginaries. We use exactly the same formulas you guys already know. So, we're going to take this point, which is in rectangular, real part, plus or minus, and imaginary part, and we're going to get rid of the x and we're going to get rid of the y, because in polar you don't have an x and a y, you have an r and a theta. We just have to remember what we change x to. Does anyone remember from earlier in the week? It has a trig function in it. Something uses, can't really tell you too much without just giving you the answer. Yeah?
It wasn't Pythagorean to do
No, not Pythagorean theorem. It was the first day we put them in a box and we said to convert from rectangular to polar, x equals this, and then y equals, it's almost the same thing, but it's a different trig function. Please?
r cosine theta.
Yeah. So x is r cosine theta. Again, the reason why we We did that on Monday. And what about y? Yep, Francisco?
R sine theta.
R sine theta. So all we have to do to write a complex number in polar is instead of putting x, put r cosine theta in place of it. And instead of putting y, put r sine theta. All right, so let's do that. So we get r cosine theta plus the I stays right where it is. Nothing happens to that. The y changes to r sine theta. Okay, now if we look at that, we have something written twice in front of the trig function. What do both trig functions have in front of them? R. Whenever we have the same thing written twice, we can put it out in front and write it once. If I factor r out of the first thing, what's left? Nothing's left. What would be left if you take r out of the first part? Cosine theta. And what would happen if you take r out of the second part? I sine theta. That is the polar form of a complex number. You don't really have to write it twice. You just put a box around what you just wrote. Right under it, just put polar form of a complex number. It's r cosine theta plus I sine theta. So it's built off the same two formulas we learned on Monday. So what would a final answer look like? A final answer would look something like this. 2 cosine 15 degrees plus I sine 15 degrees. That's a final answer. You don't do anything else. You don't actually type this in. You don't distribute the two. That's it. That's a final answer. I mean, if the angle was 15 and the radius was 2. Now, how do we get the radius? These are the two formulas we learned yesterday. And Shelby brought one of them up earlier. Yep. So I won't write it down again, but to get r, you use the Pythagorean theorem. How do you get your angle? Yep.
The invert of tangent.
Yep, you use inverse tangent. Just remember, if you're in quadrants 2 or 3, you have to add what?
180.
180. It's the same thing we did. So it's really there's nothing different. So let's try an example. And this will be the last one. We've got square root of 3 minus I. Well, what number is in front of I, even though we didn't write it? Yeah, we can stick the 1 in there if you want to put it in. And now there's two things we have to figure out based on this coordinate. We got to figure out r. We got to figure out theta. Let's do theta first. Now, the reason we practice graphing is because when you find theta, it depends on what quadrant you're in, whether or not you add the 180. So if I were to graph this, what quadrant would it be in? Olivia?
Quadrant 4.
It's in quadrant 4. The real part is positive. The imaginary part is negative. Positive, negative puts you down there somewhere. Is quadrant 4 one of the quadrants I have to add 180? No. So theta is the inverse tangent of, and remember, y over x. This is like your y, remember the imaginary, that's the up and down. The real part is like your x, that's left and right, just like on the grid we just did. So what would go on top in my fraction?
-1.
-1. Divided by?
3.
Say it again.
-1 divided by 3, right?
Square root of 3.
Square root of 3. Yep. Okay, so type that in and then see what we got. Okay, I'm already in degrees, so I'll get an answer in degrees. Inverse tangent, -1 divided by square root 3. Negative 30 degrees. Or, what can you add to that number if, let's say they wanted it positive? This is the same rule for this too. Yep.
Yeah, 360.
You can add 360. The directions didn't say to make this positive. I would like to make this angle positive. That's all. So there's your angle. So we know what we're going to fill in here and here. We just need r. And what theorem do we use again to get r? The Pythagorean theorem. Here's your triangle. You went right square root of 3 down 1. So let's set that up. X squared plus y squared equals r squared. X is the square root of 3. Square it. Y is -1. Square it. So x squared plus y squared equals r squared. What's x squared?
3.
Just 3, right? Square root, gone. What's -1 squared?
1.
1. 3 plus 1
4. 4 squared is 2.
gives me 4. And square root of 4?
Yeah, the square root of 4 is
2. There's my radius. Now I know what I'm going to fill in here. Once I fill in those numbers, you just stop. You're done, you just leave it like that. So the answer is r cosine theta. So it's going to be r cosine theta. So r is 2, theta is 330. Plus I sine theta. Parentheses. There's your answer. Okay. The reason you don't do this out is because if you took the cosine of 330 and multiplied it by 2, you would get this. If you took the sine of 330 and distributed the 2, you would get that. So if you did it out, you would be changing it back to what you started with. That's why you don't do it out. It might be a good way to check your answer if you want to distribute it and see. But you leave it just like that. Any questions on that? Okay, so what's kind of nice is you use the same formulas. If you're making a reference sheet, which you can for the test, you don't have to put any new formulas to find theta, it's still the inverse tangent, or to find r, it's still Pythagorean theorem. You might just want to write down what's in this box though. That form, r cosine theta plus I sine theta. That's the only thing that's new. Any questions on that? So on Monday we'll finish up and you'll see how writing something in polar like this makes multiplication and division super easy. You can do it in your head without any work at all. So we'll see that on Monday. And that'll be a pretty short lesson, so we'll have time to answer any questions that you may have or anything you want to review from this week for the test on Tuesday. All right, so I'm giving you guys a ton of time today to start the homework. You got about 30 minutes. So please use the time to try to get started on it. If you finish it, then you don't have anything to do over the weekend. Okay, so page 560, that's 15 to 27 odd, and 28. It's all multiplying and dividing. And then 11 to 19 odd, that's converting complex numbers to whole.